Ultratech International is pleased to introduce the new Ultra Drum Spacer. The Ultra Drum Spacer is an innovative drum tier indexing spacer that was developed in conjunction with Idaho National Engineering Laboratory to help solve their long-term drum storage needs. The benefits the Ultra Drum Spacer offers at INL will also benefit other Department of Energy facilities. These facilities are turning more frequently to long-term storage of drum packaged waste and therefore require a safe and cost-effective means of stacking drums. This video is not a polished sales video with dramatic background music and fancy graphics. It is a simple means to show other DOE facilities this new product, how it works, what benefits it can offer, and why it was developed. In the next 7 minutes, you will see the Ultra Drum Spacer in actual use, see how the product turns loose drums into a solid stack, hear from the product's designers, and hear an INL equipment operator. Let me review some of the Ultra Drum Spacer's specifications. There is a design that will hold 8 55-gallon steel drums. It is molded in 2 4-drum sections and bonded together to form the 8-pack. It is also available as a 4-pack. The second design will hold 6 83-gallon steel salvage drums. It is molded in a 4-drum section and bonded to a molded 2-drum section. In this model, a 2-pack, 4-pack, 6-pack, or 8-pack design is possible. The Ultra Drum Spacer is constructed of Xurex, an innovative polymer that is uniquely suited to meet the demands of this application. Xurex is a special polyurethane blend that offers tough, crack resistance performance, smooth surface finish, excellent chemical resistance, long life, and durability. The Xurex is resin injection molded into precise molds to produce parts which meet close tolerances and design requirements. The Ultra Drum Spacer has benefits that are not available with drum spacer technology being offered today. The Ultra Drum Spacer design was determined to provide seismic safety up to a 6.2 Richter scale event. This analysis was done on a supercomputer, which modeled the event based on 55 and 83-gallon drums stacked 5 high using the Ultra Drum Spacer design. This computer modeling allowed Idaho state officials, along with DOE counterparts, to approve stacking beyond the typical 3-tier height to 5-high stacking. This has let INL gain significant savings by fully utilizing its long-term storage facilities. INL has an EPA consent order which allows a dense pack array that is 4 drums wide and 24 drums deep using these spacers. The Ultra Drum Spacers also offer the ability to be reused over and over again. The smooth, non-porous surface makes decontaminating the units easy. The life expectancy of the units make them truly long-term storage spacers with no maintenance needs or problems. The design was modified to meet the handling needs of forklift operators and provides maximum ease of use when loading the drums. In fact, preliminary tests are indicating that spotters may not be required to be near the drums when the loading of the spacers is taking place. The drum spacers create one solid unit out of a stack of 40 individual drums, typically loose by nature. By taking on the form of a single unit, seismic safety is accomplished, as well as warding off accidents due to unintentional bumps or mishandled drums. The stacked drums can be made to sway slightly, but remain as a unit. Even a forklift banging into a stack will not cause tumbling drums based on the speed in which this test occurred. Of course, no product can meet all potential challenges and problems, and the Ultra Drum Spacer has its limits as well. But for strong earthquakes and limited forklift bumps, the Ultra Drum Spacer does offer significant protection. Another key benefit of the Ultra Drum Spacer is its ease of use. Your equipment operators will find the spacers are easier to use than the current plywood sheets, which offer no alignment and allow drums to slide around during handling and seismic events. Even shelving systems can be limiting in the space and visual contact they offer the operator. The indexing ring is designed to allow the forklift operator to feel the drum settle into place. The smooth surface also allows the drums to slide into the index position with ease. The spacer design follows the contour of the drums, allowing the operator maximum visual contact as the drums are positioned onto the stack. The indexing rings are tall and thick enough that with some experience, drums can be placed 5 layers up without the aid of spotters, eliminating the need for spotters To be near the drums is a tremendous benefit, as it eliminates the Alera concerns with worker exposure and safety. This benefit alone has significant cost savings, as well as benefit to the employees.
Hi, I'm Mark Shaw. I'm with Ultratech International. I'm here today to tell you about a new product that's designed for drum storage. It's a drum tier indexing spacer. It's jointly developed with INEL, Idaho National Engineering Lab, and their subcontractor EG&G, as well as Ultratech International's engineers. With me today is Dennis Wilkinson. Dennis is with the Idaho National Engineering Lab and is a principal nuclear operations specialist who's involved in projects like this. Dennis has been involved in the design and concept of this from the start, and I thought he could tell you a few reasons why INEL felt it was necessary to develop a product like this and make it available for their own use. Dennis, what was the thought process behind coming up with this product?
Well, initially we were in the midst of applying for a Murphy permit, which required a dense pack stacking arrangement of mixed transuranic waste in loose storage modules within our facility. The dense pack initially was designed with seismic stability, as a primary concern because of the amount of space that was available to us. We were looking at a 5-high stack with a 2x4 drum configuration, 24 drums deep. Because of our RECRA permit considerations and constraints, we were allowed a very narrow and fairly limited amount of space for storage. We still have the requirements of inspection. We still have to get in and visually look at containers, which was quite a problem with the current methodology that was being used. The indexing spacer design actually gives us a raised indexing lip which captivates the drum above and below it. What that means from a stability standpoint is that it literally locks the column in place in a vertical as well as an XY or an XYZ coordinate, thus tying the whole stack together. So the stack is fluid and acts as one body opposed to many bodies.
I see. So in an earthquake, for instance, these drums then wouldn't be toppling over at random. Instead, they would move together in a predetermined or controlled design, much the way the tall skyscrapers are allowed to move a little bit but remain together very well.
Exactly, Mark. We did seismic evaluations for a 6.2 event.
I see.
And without a problem. We initially thought we were going to have to tie layers of drums together, which because of the analysis proved we wouldn't have to do that. Another advantage to this type of an arrangement is the lack of additional personnel and the Alera exposure that we would have ended up absorbing
now,
all the personnel.
Alera exposure, for those of us who aren't aware what the term
as
Alera
low as reasonably achievable.
Okay, so that the worker exposure then by using this product is greatly reduced.
We're very concerned about ionizing radiation and its effect on workers. We have a lot of drums in storage. This is going to be a long-term event. In moving those into RECRA-approved storage, worker safety is a big concern to us, and our annual goals would have been exceeded had we stayed with our current methodology.
So you have a certain amount of worker exposure allotted or a goal that you want to achieve. The use of this system is going to at least save you some of those allotted hours of worker exposure. You can either use elsewhere where needed or simply reduce worker exposure throughout your facility.
Like we have drums in storage currently that are using a fire retardant plywood. The problem with the plywood is, number one, that there's a friction coefficient problem where the drums slide very easily on the plywood, We have a humidity factor that causes the magnesium chloride that's used as a retardant to leach out and end up running down the drums and ending up in the chime rings. Magnesium chloride is a salt, and what's happening is it's attacking the surface finish and causing premature degradation on the containment finish.
Would those plywood separators have provided the same seismic safety that this product would?
Not at all. The plywood was strictly a mechanism to have elevated tiers and drums. We didn't even attempt to do seismic stability calculations. It was very expensive to do it on this product. We knew that we had secondary problems, magnesium chloride being the primary one, which would really not allow us to go much further. In addition to that, plywood is a very porous material. If we were to have leaks from containers, they would end up becoming part of the waste.
Almost like sponge.
They're literally, because of the porosity of the surface of the plywood, they would end up soaking up the material, and they could ultimately be waste.
You know, what were the reasons that you decided this was a material that was worth this consideration, this application?
Well, in the design, we wanted something that would provide chemical resistance from the matrices of waste that we would be storing on them. We were looking at something that had a great deal of impact resistance, high strength, lightweight. We also wanted something that would be reusable and deconnable. This has there's zero porosity in this, so the possibility of radioisotopes or radioactive chemicals impregnating this material is about zero. This would be very easy to clean up because of the surfaces. I think they'll prove to be very useful in our application.
Great. Can we just go ahead and show how this sits up on top of the top stack there? Okay, so then the next layer of drums will be placed on top of that?
That's correct. And we would go up to a five-tier stack. And you notice the thing locks in place. It literally locks all of the drums together. There's no outside, it doesn't protrude outside the edge of the drum ring, which gives our operators less confidence because it doesn't appear that it has the type of structural integrity that it really does.
Jim Baster is an equipment operator with the Idaho National Engineering Lab. While it is difficult to hear because of background noise, Jim offered the following comments based on his experience with using the Ultra drum spacers. The drum spacers were easy to use, required less worker exposure, may not require spotters, and would therefore eliminate a major Alera concern. He thought the drum spacers were easier to use than shelving or plywood. Jim recommends the Ultra drum spacers for use even if you're stacking only 3 drums high.
I'm with Larry Bierce, who's with Ultratech International. He's Vice President of Engineering. And Larry was involved on the design work on this, coordinating with INL and Dennis Wilkinson, who was the principal engineer for INL in this project. Larry, one of your involvements in this was the material selection. Can you tell us a little bit about the Xurex material and why Xurex and not, say, polyethylene, fiberglass, or steel?
Our first selection would have been polyethylene. The problems with that are that in this type of application where you have a high point loading on the material, it tends to extrude or creep. Therefore, under long-term storage conditions, the stack would not be stable. Also considered fiberglass, which might have been a good material. It has some problems of flammability and brittleness. It breaks very easily. Xurex is an extremely tough material, even in its unfilled condition, and is easily injection molded and doesn't have the abrasive properties that the fiberglass does.